मॉर्निंग फ्रेंड्स, मीट नॉलेज हब में आपका वेलकम है। और सेम रिवीजन सीरीज को कंटिन्यू करते हुए हम इलेक्ट्रॉनिक्स का ही नेक्स्ट टॉपिक डिस्कस करेंगे, ट्रांजिस्टर। ट्रांजिस्टर कंसिस्ट ऑफ टू पीएन जंक्शन formed by sandwiching either p type or n type semiconductor between a pair of opposite type. In practice, these three blocks NPN are grown out of the same crystal by adding corresponding impurities in turn. An NPN transistor is composed of two N-type semiconductors separating by a thin section of P-type. However, a PNP transistor is formed by two P sections separating by a thin section of N-type. In each type of transistor, the following points may be noted. First is, there are two PN junctions. Therefore, a transistor may be regarded as a combination of two diodes connected back to back. Second is, these are three terminals, each taken from each type of semiconductor. And third is, the middle section is very thin layer. This is the most important factor in this function transistor. Okay, next is origin of the name. That why we call it transistor. A transistor has two PN junction. One junction is forward biased and the other is reverse biased. The forward biased junction has a low resistance path, whereas a reverse biased junction has a high resistance path. And the weak signal is introduced in the low resistance and output is taken from the high resistance circuit. Therefore, a transistor transfers a signal from a low resistance to high resistance. The prefix trans means the signal transfer property of device, while ISTER classifies it as a solid element in the same general family with resistors. So, this is the reason why we call it transistor. Okay, and next is intro of terminals of transistors. The transistor has three sections of doped semiconductors. The section on the one side is the emitter and the section on the opposite side is the collector. The middle section is called the base and forms two junctions between the emitter and the collector. Okay, let's discuss emitter. The section on one side that supplies charge carriers is called the emitter. The emitter is always forward biased with respect to base so that it can supply a large number of majority carriers. The emitter of PNP transistor is forward biased and supplies whole charges to its junction with the base. Similarly, the emitter of NPN transistor has a forward biased and supplies free electrons to its junction with the base. Next is collector. The section on the other side that collects the charges is called the collector. The collector is always reverse biased. Its function is to remove charges from its junction with base. In PNP transistor, it receives whole charges that flows in the output circuit, and in NPN transistor, it receives electrons. Next, third terminal is base. The middle section which forms two PN junctions between the emitter and collector is called the base. The base emitter junction is in always forward biased and it allows low resistance for the emitter circuit. And the base collector junction is always in reverse biased and provides high resistance in the collector circuit. Okay, let's discuss about transistor symbols. There are two particular symbols for NPN and PNP as shown in figure. Note that emitter is shown by an arrow which indicates the direction of conventional current flows with forward bias. For NPN connection, it flows out of the emitter as indicated by outgoing arrow, and for PNP it is inward. And for let's discuss some facts about the transistor. First is the transistor has three regions, namely emitter, base and collector. The base is much thinner than emitter while collector is wider than both, because during transistor operation much heat is produced at the collector junction. The collector is made larger to dissipate the heat. And second is the emitter is heavily doped so that it can inject a large number of charge carriers into the base. The base is lightly doped and very thin. It passes most of the emitter injected charge carriers to the collector. The collector is moderately doped. Next is the transistor has two PN junctions, therefore it is like two diodes. The junction between emitter and base may be called emitter base diode or emitter diode, and the junction between the base and collector may be called collector base diode. Next, fourth point is the emitter diode is always forward biased, whereas collector diode is always in reverse bias. The resistance of emitter diode is very small as compared to collector diode. Therefore, the forward bias applied to the emitter diode is generally very small, whereas reverse bias on the collector diode is very higher. Okay, next topic is working two transistors. It is seen that emitter current entirely flows in the collector circuit. Therefore, the current in the collector circuit depends upon the emitter current. If the emitter current is 0, then the collector current is nearly 0. However, if the emitter current is 1 microammeter, then collector current is also about 1 microammeter. Now we will discuss working of PNP transistor. In PNP transistor, the emitter base junction is always forward biased and the collector base junction is always reverse biased. The forward bias causes holes in p-type emitter to flow towards the base, and this constitutes the emitter current IE. As these holes cross into the n-type base, they tend to combine with electrons. As the base is lightly doped and very thin, therefore only a few holes combine with the electrons, less than 5%, and the remainder cross into the collector region to constitute collector current IC, as shown in the figure. In this way, almost the entire emitter current flows in the collector circuit. It may be noted that current conduction within PNP junction is by holes. However, in the external connecting wires, the current is still by electrons. Okay, now we will discuss working of NPN transistors. The forward bias causes the electrons in the n-type emitter to flow towards the base. This constitutes the emitter current IE. As these electrons flow through the p-type base, they tend to combine with the holes to constitute base current IB. The electrons which combine with holes become valence electrons, and then as valence electrons they flow down through holes and into the external base lead. This constitutes base current IB. The remainder cross over into the collector region to constitute collector current IC, and in the way almost the entire emitter current flows in the collector circuit. It is clear that emitter current is the sum of collector and base current. Therefore, IE is equal to IB plus IC. Okay, now we will discuss connections of the transistor. There are three types of connection: common base connection, common emitter connection, common collector connection. But common base connection is more important, so we will discuss only common base connection and its characteristics. So first is common base connection. In this circuit arrangement, input is applied between emitter and base, and output circuit is taken from collector and base. Here base of the transistor is common to both input and output circuit, and hence the name common base connection. Next is characteristics of common base connection. The complete electrical behavior of a transistor can be described by stating the interrelation of the various current and voltage. These relationships can be displayed graphically, and the curves thus obtained are known as the characteristics of the transistor. Now there are two types of characteristics: input and output. First type is input characteristics. It is the curve between emitter current IE and emitter base voltage VEB at constant collector base voltage VCB. The emitter current is generally taken along y-axis and emitter base voltage along x-axis. The figure shows the input characteristics of a transistor in common base arrangement. Following points may be noted from these characteristics. Emitter current IE increases rapidly with small increase in emitter base voltage VEB. It means that input resistance is very small. What is input resistance here? It is the ratio of change in emitter base voltage, means delta VEB, to the resulting change in emitter current delta IE at constant VCB. Therefore, RA is equal to delta VBE upon delta IE at constant VCB. As a very small VEB is sufficient to produce a large flow of emitter current IE. Therefore, input resistance is quite small, of the order of a few ohms. Next is output characteristics. It is the curve between collector current IC and collector base voltage VCB at constant emitter current IE. Generally, the collector current is taken along y-axis and VCB along x-axis. The following figure shows the output characteristics of a transistor in common base arrangement. We can see there are three reasons of the output characteristics. The shaded region towards the left is called saturation region, and in this region both the junction are in forward bias. This shaded region lying below the curve for IE is equal to 0 is called cutoff region. In this region both the junctions are in reverse bias. The non-shaded central region of the output characteristics is called active region. In this region, the emitter base junction is forward biased and the base collector junction is reverse biased. The following points may be noted from these characteristics. First is the collector current IC varies with VCB only at very low voltage, less than 1 volt, and the transistor is never operated in this region. Second is when the value of VCB is raised above 1 to 2 volts, the collector current becomes constant as indicated by straight horizontal curves. It means that now IC is independent of VCB and depends upon IE only. This is consistent with the theory that the emitter current flows almost entirely to the collector terminal. The transistor is always operated in this region. Third is a very large change in the collector base voltage produces only a teeny change in collector current. This means that output resistance is very high. The value of output resistance RO will be equal to delta VCB upon delta C at constant IE. Okay friends, time complete हो गया है and topic is also completed. So next lecture मिलते हैं new topic के साथ. Okay, see you soon. Thank you.